Combat aircraft have always been the pride of the United States. No other country in the world can match the size of the U.S. Combat Air Force or its quality. Many aircraft with American white stars on their wings have become legends with the prefixes first or most. The first and best third-generation F-4 Phantom II fighter, the best and most mass-produced fourth-generation F-16 Fighting Falcon, the first and best fifth-generation F-22 Raptor fighter, the highest altitude and fastest production aircraft, the Lockheed SR-71 Blackbird. The list goes on, but leadership needs to be constantly reaffirmed. The 30s are coming, in which the sky will belong to completely different airplanes. What will they be? In this video, we're going to tell you about the American project that'll determine the shape of combat aviation starting from the 30s and at least until the middle of our century. Conquering superiority in the air and space sphere remains for the U.S. a prerequisite for achieving its goals in military conflicts. According to military experts, in the initial period of the war, the NATO air grouping should be able to hit up to 100,000 targets day and night in various physiographic and meteorological conditions. At the same time, it should be taken into account that the defeat will take place in conditions of tough counteraction of the enemy air defense and its aircraft. Hence, we can see how important is the correct choice of the concept of future aircraft and its perfect technical realization. Modern combat aviation consists of three main classes of aircraft: strategic bombers, fighters with the function of tactical bombers, and attack aircraft. Consider what the U.S. plans to have by the 2030s in each class. Strategic bombers. After the start of flight testing of the B-21 Raider, this class has the greatest certainty. It was forced to this in objective circumstances. According to Pentagon analyst calculations, by 2037, the total number of B-52, B-1, and B-2 aircraft will be less than 170 units. i.e., it'll be less than the minimum allowable number of the total fleet of strategic aircraft of the U.S. Air Force. And the development of the B-1 and B-2 did not justify itself. Supersonic B-1 turned out to be the least demanded type of aircraft for combat operations, while such bombers were in the line of 100 units. Although it has even greater combat load, 34 tons compared to 31.5 tons in the B-52, but is much more expensive in operation. The bet on supersonic proved to be a losing proposition, and the low observable subsonic B-2 Spirit turned out to be the most expensive airplane in the world with a prohibitive cost of $2 billion. In addition, the cost of one of its flight hours passed the mark of $170,000. At the same time, for each flight hour, it required 60 man-hours of complex maintenance. This led to the fact that Spirit was built only 20 units, and they can operate only in the United States. The advent of the subsonic B-21 Raider seems to solve many problems. First, it's a modern airplane that incorporates all modern stealth technologies, which makes it very difficult for the enemy to identify and destroy it. Secondly, its cost is almost 3 times lower than that of the B-2 Spirit and is $750 million. The cost of its operation is also noticeably lower. Third, it has a highly sensitive radar, which allows the aircraft to effectively strike and effectively defend. And finally, it has a huge reserve for modernization, in particular for the installation of new hypersonic cruise missiles and even laser weapons. The planned procurement volume of the B-21 is about 80 to 100 machines, with the possibility of increasing the order book to 145 machines. Fighter jets. Unlike strategic bombers, there's no great clarity here. The U.S. has 2 programs for the development of the 6th-generation fighter, FA-XX for the Navy and NGAD for the Air Force. The programs are, of course, strictly classified. However, according to leaked information, we can already outline the appearance of this aircraft and its capabilities. First, we note that it'll certainly be. The first thing is stealth. Over the past decades, air defense has made a great leap forward, and now neither great speed nor outstanding maneuverability no longer save. One hope for stealth, which should be much higher than that of the 5th-generation vehicles, Therefore, no keels, but only the tailless scheme as in the B-2 Spirit and B-21 Raider. The second is the presence of winged UAVs. Low stealth only narrows the range of enemy air defense but does not eliminate it. And if it's necessary to fulfill tasks in this zone, no one will risk either the pilot or the machine, which is worth several $100 million. Drones controlled from the airplane will be sent there. But why turn a fighter jet into a drone control point? Wouldn't it be easier to do it from the ground? The problem is that UAVs have yet to become fully autonomous, and sending signals from several thousand kilometers away means delays. In modern air combat, where fractions of seconds make all the difference, such delays are fatal. In addition, in a serious conflict, both sides will actively use all kinds of jammers, therefore it's better to stay close to your drones at such moments. The third is versatility. A modern airplane is a very expensive product, costing several $million. No one will make a lot of them, not even such a rich country as the United States. Therefore, the machines must perform several functions at once: the conquest of air supremacy and reconnaissance and strikes on land and sea targets. Hence the presence on board of long-range, high-speed missiles, not only air-to-air but also air-to-surface. The F-35 can be considered the first such aircraft, but according to the almost unanimous opinion of experts, because of this versatility, the airplane cannot be considered a fifth-generation machine by some criteria. It has no supersonic without an afterburner and no supermaneuverability. The fourth is network centricity. Modern warfare is unthinkable without real-time intelligence sharing and target designation. After all, targets are often outside the radar range of an airplane. And now about those capabilities of the sixth-generation fighter that are in question. The first is hypersonic speed. It would seem that the higher the speed, the more chances to evade anti-aircraft missiles and air-to-air missiles. Now their maximum speed is somewhere around Mach 4. So at hypersonic speed, which is higher than Mach 5, these missiles will become non-threatening. But it should be understood that it's much easier to make a hypersonic missile than a hypersonic airplane. And if they appear, then soon there will be hypersonic missiles to destroy them. In this, we cannot doubt. At the same time, the presence of hypersonic raises many problems. First is the issue of invisibility. The higher the speed, the higher their aerodynamic drag, and the higher the heating, which can be detected by infrared sensors, which are already on the Russian Su-35, and are going to be put on the F-22. By the way, on the latter, to reduce infrared visibility, the nose and lantern of the cockpit force cooling. So the Predator has a speed of Mach 2.2, and here at least 5 Mach. By the way, aerodynamic drag is proportional to the square of speed. Secondly, launching a missile from an airplane traveling at hypersonic speed is a difficult technical problem. And thirdly, fuel consumption increases sharply, which affects the range of flight. In short, there are big doubts that the sixth-generation aircraft will be hypersonic, perhaps optionally and for a short period. The second is supermaneuverability. The concept that dogfights, so close-range combat, are a thing of the past, is now more and more prevalent. Defeating the enemy will be done from long range. The F-35 is the embodiment of this concept. By and large, the airplane will not be able to dodge the missile. In any case, its maneuverability will be higher. Indeed, if the airplane's maximum overload is 9 to 10 G, the missile's maximum overload is 30 to 40 G. And it's not even the presence of a person on board. At high loads, the airplane's wings will simply fall off, which the rocket simply does not have. The third thing is the presence of a pilot. With the rapid development of artificial intelligence, the question of the advisability of having a human in the airplane is being raised more and more often. Even now, fifth-generation airplanes cannot fly without a computer. They're aerodynamically unstable. So, can we remove the pilot altogether? The question is debatable. On one hand, the absence of a person on board solves many problems at once, starting with the physiological limitations of the human body on overload and flight duration, and ending with moral and ethical problems of possible death of the pilot. On the other hand, in case of electronic failure, the consequences can be fatal. After all, there could be nuclear weapons on board the airplane, and God knows what'll go into the head of artificial intelligence. Now the prevailing viewpoint is that it's necessary to develop two versions of the aircraft, unmanned and manned, but with maximum transfer of functions to artificial intelligence. For example, to fully transfer control of the winged drones to it. The fourth is the presence on board of weapons based on other physical principles. These are, first of all, lasers. Lockheed Martin has made great progress in this area. It's assumed that lasers should defeat the means of electronic suppression of the enemy and disable the homing heads of missiles of any type. It's also envisaged to introduce computer viruses at a great distance. In other words, the defeat of air defense systems will not be done by impact weapons, but by disabling the systems with a virus. The Pentagon plans to start delivering the sixth-generation fighters to the troops in the mid-30s. They're expected to replace the F-22 Raptor. The U.S. Air Force is expected to initially buy 200 NGAD fighters and 1,000 unmanned combat aerial vehicles, assuming 2 such drones for each NGAD fighter and 2 more for each of the 300 fifth-generation F-35 fighters. Attack aircraft. There is no clarity on this issue at all. What to replace the legendary Warthog, the A-10 Thunderbolt II attack aircraft, which is already half a century old, is completely unclear. A few years ago, the military tried an attack aircraft stealth fighter F-35 Lightning II, which was designed, among other things, for direct support of troops. Judging by the sepulchral silence of Pentagon officials, the F-35 turned out to be not very good as an attack aircraft. After all, the Pentagon initially wanted to write off the Warthogs before the end of the decade. At least that's what officials officially said in September 2019. But as early as April 2020, plans changed. The fleet of 281 attack aircraft will be reduced by 44 aircraft with the shortest service life. The remaining ones will be fitted with new communications equipment and will remain in service until 2040. It seems to us that the attack aircraft role will eventually be a UAV that'll be controlled either from the ground or from an airplane. Still the same A-10 or F-35. Most recently, General Atomics Mojave Short Takeoff and Landing Drone, armed with a pair of Dillon Aero DAP-6 minigun cannon launchers, was successfully tested. Looks like something similar is finally coming to replace the well-deserved veteran. What do you think? What kind of airplanes will be in 10 years? Share your thoughts in the comments. We'd be glad to get your thumbs up and subscriptions to our channel about modern weapons. See you soon.